Hi, my name is Yachana. Today, I and my group members did an experimental studies of fast reaction for flow techniques and also relaxation techniques. Okay, for now, I'm going to discuss about the introduction, principle of techniques, and also the apparatus required for the fast reaction methods. What is fast reaction? Okay, fast reaction is defined as the best term to reaction that can't be followed kinetically by conventional method. Okay, we can't say that a reaction with large rate constant is a fast reaction, because fast reaction is more likely temperature dependent, where we can say that it's more accurate to assume that fast reaction will have lower activation energy. There are a lot of examples of fast reaction. One of it, when we carry out neutralization process at labs between hydrochloric acid and sodium chloride where salt is formed. It is also known as a fast reaction where we carry out in labs. We have two techniques in this fast reaction. Okay, the first one will be flow techniques and the another one will be relaxation techniques. Okay, first let me explain about flow techniques. Okay, flow techniques is a technique that uses special mixing chamber to study the chemical kinetics of reaction in solution. There are actually different various ways that can be implanted depending on the nature of the reaction. Whereas relaxation method is an alternative technique to approach for the rapid mixing. It studies the dynamics of biological mechanism. These techniques works by determining the rapid change in pressure or temperature, which can alter the composition of reaction that has already achieved equilibrium. The methods that are available under flow techniques are top flow approach, sequence flow approach, and continuous flow approach. And the methods available under relaxation techniques are flash photolysis and temperature jump. Okay, as I mentioned in the previous slide, there are various methods to carry out these flow techniques. So first, I'm going to talk about stop flow method. Okay, the apparatus are needed for the stop flow methods are two types of solution: mixing chambers, syringes, where it is used to pump and also stop the reaction, and it will be prepared as shown in the slide. And the second method that is available in flow techniques is continuous flow method. Okay, the apparatus also will be prepared as shown in the figure in the slide, and the apparatus are needed is a long tube, two reactant gases, and a movable detector, and also a spectrometer where the result will be obtained. If needed, we can add on an indicator to adjust the ratio of the reactant. And another method that is available with flow techniques is sequence flow approach. The apparatus are needed are syringes, reagent valve, mixer, aging loop, collection valve, sample collection loop. The apparatus will be prepared as shown in the figure shown in the slide. As we see for relaxation techniques, the method available is temperature jump. So I'm going to discuss the apparatus needed for temperature jump. The apparatus needed for temperature jump are syringes, optical cell, and a power supply, and it will be prepared as shown in the figure in the slide that I have shown. And another method that is available under relaxation method is flash photolysis. Okay, for the flash photolysis, the apparatus needed is gases, spectroflash, reaction vessel, photolysis flash lamp, and also a spectrograph to read the result. So these are the apparatus needed for flow techniques and also relaxation techniques, and it will be prepared according to the picture shown in the slides.
Hi, my name is Nurain, and I'm going to present about the methodology for fast reaction for flow techniques and relaxation techniques. So in stop flow method, shrink are filled with the A and B solution and compressed to small amount, approximately about 50 to 100 microliter, then stop. Once flow is stopped, solution edges with time can be controlled. Detector sees more than one edge. low dead times, and this method uses a expensive detection system. In quench method, solutions are driven through a high efficiency mixer and flow into a delay or aging loop, and after set time, reaction is stopped by the addition of a chemical quench solution. Each time are controlled by the speed and duration of a single push or by the two pushes of the shrink, and small volumes of solutions are required for this method. For the last method for flow techniques, we call it the continuous flow method, where shrink are filled with the A and B solution and compressed at constant rate. Flow rate must exceed turbulent limit. H-old solution is proportional to flow tube distance and flow rate. Only one time point H per measurement as per position, and large volume of solution is required for this method. In flash photolysis method, it used for the study of reactions in solution as well as those in gaseous phase. This method uses light to decompose molecules to a simpler unit, often in ions or free radicals. Short paths of light will initiate a reaction that can be observed by optical or other means, and the wavelength of the light triggers reaction can be adjusted to activate the one molecule without affecting others that might present. Another method in the relaxation techniques is a temperature jump, which provides a means to follow fast reaction with half-life of just a few microseconds. Reaction volume prepared in the equilibrium and then rapidly perturbed by a rapid change in the temperature. There is a new equilibrium constant at the higher temperature, where initial concentrations are balanced for the lower temperature. Therefore, system relax and reaction proceed until they reach their new equilibrium values.
Hello, my name is Muhammad Rajri bin Mustafa, and I'm gonna present about the application in laboratories and industry about the experimental study of fast reactions. I'm gonna start for the flow techniques in laboratories and industry. I will take a very simple example for the continuous flow method, which is been used for a decade in process development, which is processing oil. So here we will take an example about process development is the preparation process in the general name for a chemical reaction in which two reactants, typically an alcohol and an acid, form an ester as the reaction product, which is biodiesel. Ester is a common organic chemistry, and this is common use for producing for biodiesels. So here I put a schematics to show that the reaction are using the continuous flow method. So the flow techniques are being used in the lab scales before it took place at the plant processing development. Because why we need to use at the lab scale, we need to know how much the quantity, how to optimize the process to get the good product. So in the slides also I put a diagram about the continuous flow method in a plant schematic diagram, which is, you can see there are oil, alcohol, and then there are catalysts, and then they will go to a mixer. After that, and they will go for distillation and separation, and the product, which is biodiesels, at the last of the process. So that is an example of the continuous flow method in laboratories and industries. Now I'm going to continue to present about the stop flow method under the flow technique. So I will explain about the stop flow NMR, which is nuclear magnetic resonance. This is being used in the laboratories in enzymes, protein folding, redox reaction, coordination chemistry, or catalysis. As we know that stop flow NMR enables study of fast reaction using the high intrinsic information content of NMR spectroscopy The probe in the NMR exhibit a fast flow rate which is estimately 14.5 milli per second and short transport time in 2.6 milli per second that assure rapid and complete mixings and short dead time for fast reaction. Well, that is why it is being used for laboratory experiments in studying the mechanism of catalytic polymerizations. Relaxation technique in laboratories. So the example I gave in here is flash photolysis method. The flash photolysis is commonly used fast reaction technique for photochemical reaction. For reaction with a moderate rate, flash lamps provide sufficient time response. To maintain nanosecond range, flash photolysis techniques is used. We use it in laboratories because the flash photolysis system can perform transient absorption measurements within the short nanosecond range. The absorption spectrum of the formation and decay process of intermediaries in photoreactions such as photodissociations, photoisomerization reactions, and other reactions can be observed. Due to the newly developed software added with the adoption of the optics, transient absorption spectrum measurements in the nanosecond range have been made easier. And the slides already included example of flash photolysis instrument that being used in laboratories, so you can get a clear picture about what exactly flash photolysis in the real world. Before I forgot, I'll need to explain what is the applications of this flash photolysis in the real world. Its application to the observation of the absorption spectra of excited singlet states, short-lived excited triplet states, and chemical event in the nanosecond time region are described. The method is a valuable tool for the identification of transient chemical intermediates, enhanced for the study of mechanism of fast chemical reactions. As we know, during photolysis reactions can be processed in very short time, like in nanoseconds. Let me give another example when to use this flash photolysis method in the laboratories. In laboratories experimentals, this method has been used for the studies of reactions in solutions as well as those in gaseous phase. Photochemical dissociation of iodine. If iodine vapor is illuminated with light of suitable wavelength, the dissociations occur. Under steady illumination with light of moderate intensity, steady state is reached with only a very small fraction of iodine dissociated into atoms. This steady state is obtained when the rate of photochemical dissociation of iodine molecule and non-photochemical recombination of iodine atom equal each other. This is a great advantage of flash photolysis technique is that the technique usually necessary that the photolytic and monitoring pulse be a shorter duration than the processes to be studied. For nanosecond event, the giant pulse laser provide a mean of generation of bursts of ultraviolet radiation sufficiently energetic for the purpose of flash photolysis of duration less than or equal to 20 nanoseconds.